Hi, everybody, and thanks for attending today's webinar, Secure Docker Containers with Chef, Securely Scale Container Utilization in Production. My name is Erin, and I'm on the marketing team here at Chef. I'm happy to introduce today's speakers on this webinar as Galen Emery, Lead Compliance Architect, Ken Langdon, Solutions Architect, and Neve Cahill, Solution Architect Manager here at Chef. Before I turn it over to these three, I have a couple housekeeping items to cover. If you have any questions, you can submit them in the Q&A section at any time, and we will probably be answering questions at the end of the presentation if it's not a question pertinent to something that is currently happening. For the best viewing experience, we recommend closing any additional programs or browser sessions running in the background, as webinars are bandwidth intensive. And finally, this webinar is being recorded, and an on-demand version of the presentation will be available by tomorrow. So for those of you just joining, welcome to today's presentation, Secure Docker Containers with Chef, Securely Scale Container Utilization in Production. Let's go ahead and get started. Galen, over to you.
Thanks, Erin. Really appreciate it. So today we're going to talk through the state of container security and how we can approach container security with Chef. So we'll give you a little bit of our perspective of the world, the state, how we think about solving the problem. There'll be a demo and then some key takeaways, and we'll have some time for Q&A. So the first step is let's talk about what happens with containers and what we're really trying to work with here. One of the, I think Neve, you're the one who found this, but this is one of my favorite Dilbert cartoons recently. Just rub some Kubernetes on it, right?
Yeah, I love this cartoon simply because I think we've all been there in that, somebody in your organization or, higher up the food chain comes to you and has this bright idea that Kubernetes or containerization technologies are going to solve a lot of the issues. And it is true that they're a really good fit for certain use cases, but across the board for your entire application portfolio, it becomes a lot more challenging. So that's what we're going to talk about today, is really about how to leverage the Chef solution portfolio to really practically start to adopt containers in a more scalable manner without having to, put up with input from your pointy-haired boss. So back to you, Galen.
And I always like to add that, we jump into these technologies without really knowing what we're getting into, and then all of a sudden it becomes, it's part of our ecosystem, and it's like, where did that come from, and why are we having these vulnerabilities?
Yeah, exactly. And I think, Neve, you go to, next slide. This is what we see, right? Just because you've put the thing into a container does not mean that you've solved a set of problems you had in your organization outside of containerization, right? So first off is your cultural changes, right? How do we deal with the culture of Agile, of DevOps, of getting into cloud native and things like that? But then you see quickly following it, security and complexity are also key challenges of containers, right? You're changing your architecture stack, and there's a lot of things that change in the security model and the complexity model as a result of that. And then you see the rest of the things as you kind of go through it there. But the basic structure here is, again, the modernization process does not solve just by going to containers, right? So we really need to make sure we look at all those problems and figuring it out. Lack of skills is a key component. Migrating from monolith applications, what's inside of a monolithic application, dealing with the security and compliance concerns of containerization of a familial infrastructure, the tactical infrastructure, right? All the way down the list, all the way down to identifying the business case for what we actually want to put into the cloud and put into containers. And so what we see here is that oftentimes in the security world in particular, the security world kind of lives outside of the rest of the problems, right? Like we really, they operate in a separate world. If you're in a highly regulated environment, oftentimes the security teams are glass walled away from the rest of the organization. And there's a lot of pieces that kind of come into play here. Neve, what are your thoughts?
Yeah, I think that it's a challenge for all of us, right? Because on the operations side, very often we know how to build a container, we know how to scan it for vulnerable libraries potentially, and there's a lot of tools out there that do that very, very well. But then you end up with multiple CI/CD pipelines. So there might be a continuous integration process that's specific to containers and Kubernetes, but then you might want to bring that same velocity and same approach to other applications in your portfolio. And it's a really steep curve depending on what you're trying to do. So I think a lot of us started off with just looking at containers in the lab and for, development purposes, and that was great. But now we're reaching a point in the maturity level where, you have to get out the door and make this a reality in production. And I think there's a lot of us, and I put myself into this bucket as well, who are really trying to get up to speed on not just containers, but overall, how do I deploy to Kubernetes? How do I best utilize and leverage, CI/CD for my existing applications? And how do I put all of this together in a way that's secure as well? And, we've all been there, right? Where you're doing something late at night, and if you don't have these processes in place, you commit something that you shouldn't. You end up, potentially sharing keys, or if there's a lot of different things that could happen. So what we're going to talk about today as well is just securing not only the container build process, but also the deployment steps. And, when we think about Chef, very often folks think about Chef in relation to infrastructure configuration, but our goal with Chef Inspect and Chef Habitat, the products we're going to talk about today, is really to show how you can get out the door with the broader approach by leveraging those tools and plugging them into what you have already and also extending it over to newer technologies. So Galen, Ken, I don't know if there's anything else you guys want to add there? Challenges you see out in the field?
I think you've added the right amount of color.
I would agree with Ken.
Okay. Cool.
So this leads us into, when we're thinking about this, what are some of the problems we're focused on? And I'm our compliance architect, so I focus on the security side, and Ken and Neve have a lot of perspective as well. But really, let's talk about the state of security and container security. Most of the breaches that occur in organizations take months or longer to discover. Most of the exploits, 90% or more of them, are using 9 known vulnerabilities. So we're talking about things that should have been patched but weren't. And then on the audit and kind of readiness side, they take 2 months or more to complete a security audit. And companies are still releasing software vulnerabilities at least once a year. And that's releasing software with a known vulnerability inside of it at least once a year as they go to production. And so what we see is like this continuous demand to increase the speed amplifies our existing issues around security and compliance. And obviously, this is only made worse as we get into continuous delivery and cloud native and containers, where we're going faster and faster and faster. So we really need to rethink the way that we approach the information security landscape. And so thinking about security and compliance, let's focus on the threat vectors in particular that containers have that we really need to make sure that we focus on. The first here is on the left, dependency management, right? This has become a pretty clear problem statement in the world. There's a lot of companies that do open source dependency scanning, trying to find ways in which transitive dependencies have issues. There's a lot of things that we need to really focus on. There's the base container itself. There's the application dependencies from the runtime. This is one of the things that the containers are trying to do a little bit, or trying to work us towards. And then you have a cascading dependency update. Let's say your base container has a vulnerability and you need to update the base container, which means you need to update every application that's built on that container. And if you have an application built on top of another application, then you have further chains to deal with. So you have a big problem to manage and deal with there. And just because you went to containers doesn't mean that that problem went away. In fact, you now have a sprawl problem in addition to a dependency management problem. We still have a hardening problem. If somebody or something gets onto a container or onto your Docker host, there's privilege escalation concerns. The base OS still requires hardening, and you still have to deal with a security policy within the application. That problem doesn't go away just because we're in microservices and there's a theoretical one process per container. We really do have to focus on that because, again, the sprawl of containers means that our attack surface is now a lot larger than it was back when we had monolithic applications running on big, heavy VMs. And the last thing is that if we're really serious about containers and about cloud native architecture and about artifact-based deployments, the pipeline becomes our source of truth. So we need to put our security testing into the pipeline. It's how we're going to get our speed, and really need to harden the pipeline and the artifact store to prevent unauthorized artifacts or access, because that's where production gets built from. It's from those two places. And so as we go through this today, a couple of the questions that we want you to kind of think about in the back of your heads, we're not going to stop and ask you these questions during the webinar, but as you're going through your container strategy, here are some questions that we know that are really important. And there's two in particular in bold that we really want to think about. First is, where do container images come from? Who owns it? Who owns that stack? Again, this is part of the dependency management problem. And the last one here is, how do you ensure old images with known vulnerabilities are not redeployed in production? How do you kind of cull or otherwise sanitize your image repository and image stores? So those are the two questions I really like from this. Ken or Neve, anything else in here that you want to highlight?
Yeah, just in terms of where container images come from, I think very frequently when we're starting out with images, we're building from Alpine or from a base Ubuntu image or something like that, and then you're putting your application build on top of that and running it, and then extending that out into Docker Compose or Swarm or Kubernetes, which is fine. But the two problems with that is, depending on where you're getting the image from, you may have extra libraries in there that you don't need. So you have a larger image than necessary, which means your attack vectors or your attack surface is larger. And basically you need to just take a deep look at what the settings are on your containers, which is obviously something we're going to look at today. And then, as you're building from existing containers and adding stuff on top, that issue continues to propagate itself, right? So if you have an existing application container that you're leveraging and then you update that, well, you're going to start building stuff into that in a year's time, when somebody changes the role or the person who was in charge of those images, you don't have a process around that. You just really are not terribly sure what is in that container and what the settings are that are associated with that image as well.
And Galen, I think from my perspective, as my roots are in application development, it's like exactly how are you deciding what goes in that container? What kind of applications are you going to run in that container? Those are all design considerations, and not everything belongs in a container. And I think a lot of mistakes are made in that area.
Awesome.
All right, well, let's talk about
Chef.
No, I was going to say, let's talk about Chef's approach to kind of dealing with the container threat vectors that Galen just talked about. So I'm going to start going into some detail around, how Chef's application delivery, starting with the application definition, how that's better for containers. Talk about system hardening, which applies to both the container and the host that the container is running on. And then we'll talk about how this fits into your pipeline and how we secure the pipeline. So first, we're going to start by defining the application. Now, what that means is to take all the build instructions, the configuration, how the application is installed, how you execute it, how you restart it if there's an update, all of its dependencies, which the dependencies are the big part here in a container, right? And then all the relationships with other running services, like databases, for example, that you need to interact with. All of that needs to be put into a format that can be shared, that we trust, that is testable. So we have this thing at Chef, if you can't test it, you can't trust it. And it needs to be actionable. You need to be able to parse it and do something with it. Let's with code. And so we're going to call that a manifest. So what Chef Habitat Studio provides you is an environment to define and build and test that manifest, which then can be funneled through your pipeline, which then within the pipeline produces a signed, compressed artifact, a versioned artifact, if you will, that this heart file, okay? And so then that then works through into your environment. And so wherever it is running, the Habitat supervisor basically unpacks this artifact, and everything you put in the manifest is then, executed, and it manages the application going forward. And so this is the end-to-end process, and everything you've done in that definition, from left to right, everything that's going to happen because you've defined that all in this application artifact. Now, system hardening and securing the pipeline and scanning your containers, Chef Inspec has a growing number of resources to ensure your systems and the environments where your applications are running are compliant and secure and safe, right? So defining those policies as code gives you the visibility of problems earlier in development and throughout the pipeline in an ongoing basis in production as well. So Gartner has recognized this code-based approach that we use as a best practice, and Chef is one of the leaders in this regard. So now let's wrap it together with the pipeline. So each solution that we talked about to address all the problems, they each create an artifact that we need to go through the pipeline, regardless of the deployment model. And so once you have that developed, we're going to throw that into that artifact into this human-free zone. So the application artifact we created with Chef Habitat, the audit artifact we created with Inspect, and the remediation or hardening artifact we created with Chef Infra. This structure that we've created works for containers, bare metal, VMs, anything. So we're talking about containers today, but this is a common way to do everything. So all of your teams can do a consistent thing. So, you know, consistency and structure between, you know, your containerized cloud native as well as legacy and traditional environments is achieved. And so, and Neve and I are going to kind of show you some of these things actually in action with a demo. Neve, do you want to start off with your demo?
Yeah, thank you. And just on the trusted artifact store, so Ken talked a little bit about using Habitat to package up an application deployment and define a manifest. What's really nice about that is that manifest can be leveraged to build a very minimal secure Docker container. So that is one of the artifact outputs that you could have as your build process in this pipeline. And then the flip side of that is, you know, after those artifacts have been built and you're going to run them, that's where you know, basically security, functional testing for a lot of this, because I don't know about you all, but, you know, I can run an image, but then just validating that the app launches properly, that all the settings are turned on within the container for the right, you know, network port exposure, etc. That's where the flip side of that and the compliance artifact really comes into play. And, you know, Ken mentioned about leveraging Inspect to validate the environment where you're running your container. So obviously Docker host is one of those, but more importantly, Chef Inspect also supports validating and scanning for configurations within AWS, Azure Kubernetes, your own Kubernetes clusters, etc., in addition to any local instances you might be running. Personally, I use Docker Compose locally on my machine to just do quick tests, but then obviously if I'm deploying into AKS, I want to check that my storage buckets are secure. I want to check that monitoring is turned on. I want to check that I don't have port exposures where they shouldn't be. So that's what we're going to talk about today. Cool, so this is just a slide that gives a summary of what I just described. So from left to right, if we think about the container build and deploy process and where Chef can really help out with this, Habitat really enables that very minimal image build. So we can create a Habitat package. There's lots of Habitat packages out in our open source repo already. There's about, I think, 850 at this point. But long story short, what Habitat allows you to do, and it can do many, many things, which is why I want to kind of narrow down the use case here, is it will build you a container from scratch with only the libraries and the configurations that your specific app service or app requires. Habitat can also do something straightforward like copy an off-the-shelf app binary into the Hab package and then run that within a container. Habitat also allows you to define application users that you're going to use within your container, as well as group IDs and things like that. So after you've built your container, so you may or may not be using, you may be out the door already with your image build process, and that's totally fine. But if we look at the right-hand side, that's really where we get into like a lot of the very practical matters in terms of building and running containers. So first of all, does my container work? So Inspect initially was born from RSpec, which is really functional testing that came from Ruby code. But long story short, what it does is in spec, you can start up your container as part of your pipeline and run a quick check to make sure that the application actually ran correctly, that it's listening on the right ports, etc. And at the same time, InSpec can also look at whether or not your container is compliant. And what that means is checking for settings to make sure that privilege mode is not turned on by default on your host. There's lots of other things we can validate, package versions. There's all kinds of different things. And then once you're past the functional and compliance validation, and by the way, we're going to look at some very detailed examples of that today. And you're into the deployment step. In the deployment step, you've deployed your container. The container itself really shouldn't be changing while it's running, but is your operational environment secure? So that could range from validating your Docker host configuration, your Kubernetes pod configuration. Within cloud environments, we can check for Kubernetes cloud configurations. And this is all through InSpec as well. And the nice thing about all of these different solution components is you can have this as part of your automated pipeline process, but it also reports up into our Chef Automate UI layer, which allows all of our management and leaders to have visibility into the process as well, and whether or not your images are building properly and deploying correctly, and what the configurations are for those. And it's pretty straightforward to set up. So in terms of running InSpec as part of your container pipeline, if you have a pipeline already for image builds, you can easily plug in InSpec exec into that build process. Today, if you're an existing Chef customer, you more than likely own InSpec and InSpec profiles that will allow you to do this. So I encourage you to take a look at that capability if you haven't already, because it's something that's really straightforward to do. And in terms of scanning your container configs, there's a ton of flexibility in how we can do that. So you can either do it as part of your pipeline as a local job, or you can actually initiate that from the Chef Automate layer just through a curl command, and you can actually have your InSpec scans on an ongoing basis as well. So Galen and Ken, I don't know if there was anything else that you wanted to add in there.
No, it was well stated.
Thank you. So this is just a really quick overview, and we'll be sharing this deck afterwards. But basically, when you're building a container with Habitat, why would you use Habitat to build a container anyway? Well, the fact of the matter is it makes it very straightforward. And also, if you look at this, what I've added in here is really just what the steps are when Habitat builds your container for you. And you can change these settings to align to your own environment, but what it does is it's creating, up here at the top, it's creating user habitat and group habitat. So you can specify exactly what application user you want to use. It builds from scratch every single time. We do support multi-layer containers. So if you're just basically leveraging or changing one component, it's not going to re-export the entire container every single time. You'll see that down here we can you can set up exactly how you want the container directories to be laid down, on what permissions. And then finally, it's cut off a little bit at the bottom, but you can set it to expose only the correct network ports, and then you can validate those settings with InSpec. So if we look at the image validation, so you can run an image scan as part of the pipeline. And I know that typically folks are looking at things like vulnerabilities, but what InSpec allows you to do is really programmatically expose a lot of things like Docker PS command outputs and Docker inspect of images. So a lot of the very low level information. So what I'm doing here is I'm checking to make sure that, when I start this image, that the port 9631, which is the Habitat port, is exposed, and that the port for SSH is not exposed. And basically anything that you can query about a Docker container, you can query that in InSpec. And the nice thing about InSpec is all these profiles that you're seeing here, they're available. There's a ton of open source material out there, and Chef also has a bunch of InSpec premium profiles as well that also have a lot of very good examples. Our premium profiles focus also on CIS standards for containers. So making sure that as you're building your container that it aligns to the recommendations from CIS for level 1 and level 2. So here's an example of CIS validations for that. So, you know, just making sure, it's a very basic example, making sure that my host config for my underlying Docker host is not privileged. And so we also have example Kubernetes profiles that I'm going to run through as well. So this is just exactly kind of a summary about how Habitat really makes the container build process very clean and very minimal. And if you're updating an application as a developer, for example, what you can do is Habitat can basically watch your repo, and if you know, based on usual trigger conditions, just like you would normally have in your repo, it can build a new Habitat package and by extension a new Docker image once it sees an update based on your standard triggers. So give me 1 second and we're going to switch over to the demo. So Ken and Galen, I don't know if there's anything else you wanted to add in here before we dive into the demo?
No, I'm all good. I think you've been doing a great job. We've got one question we'll get to after the demo so far. Quick reminder to everybody, if you have a question that comes up, feel free to put it in the Q&A and we'll get to it near the end of this whole shebang.
Yeah, awesome. Yep. So what I have is a national parks application. It is a Tomcat app, so pretty straightforward. We're building it using Maven, and I have an Azure DevOps pipeline. I learned a lot about Azure DevOps pipelines as part of this webinar. I've used a lot of different pipelines, but I've never really dove into a lot of the lower level tasks in ADO. So it's been an interesting experience. So what you're seeing in our pipeline here is once I push an update to my code, what's happening is my pipeline is going out and it's obviously detecting that I have that I've made an update into my national parks application. Visual Studio has a ton of out-of-the-box tasks for both Habitat, InSpec, and Chef. And so what we're doing here is just leveraging those tasks. And I'll show you exactly what the build or what the pipeline YAML definition is after this. But it goes through, and exactly like you saw in the presentation, it's going through and it's building that package, right? So here's what that package build process looks like. So in terms of visibility into exactly what libraries are going into your Docker image, this is where all those versions are laid down. And then as part of that, we have build variables that get exposed as part of that process. I've also, and then as part of that output, we're building that Habitat package. It is a heart file. And then the other section we're going to update as well is our Docker compose.yaml. So you're essentially building a new deployment package for your application. We've updated the Docker compose YAML with the new versions and the new tags that we're using. And then we're publishing our artifacts. The next step, and you can net out this pipeline however you want. You could actually have the published dev steps collapsed into the build stage as well if you wanted to do that. What we're doing is we're taking that update and we are exporting it to Docker. And that's what this process looks like here. So as you go through, again, you'll see that the Habitat package is we're pulling down all of the necessary libraries. And then at the bottom, we're going through and we are exporting to Docker. Hopefully everybody can see that okay. I know the font is a little bit small here, but we're installing the application and then we're setting it to run in the way that you specify as part of your Habitat application plan. So what this means is you are building and exporting this very minimal container. Like I said, you can specify -- multi-layer if you've only done a small change or only one portion of your application has changed. And then basically within your pipeline, that Docker image that you've built is now available locally. And what we're doing next is we are logging into the Azure container registry. We are uploading our Docker image, and then we are installing and running the inspect check. So you can see that you can just basically install inspect as part of your pipeline on your agent. You can also, if you're just playing around with this locally on your machine and doing development yourself and you don't necessarily want to run a full pipeline, you can also run inspect exec locally on your machine. I'll show you in a minute what that looks like. But as you're going through and you're doing all of these steps, basically when we run the scan of the image, it's going to output its results to our automate layer. And this is what's really nice about this. And if we go into reports here, my automate instance was misbehaving earlier. So there we go. You'll see we have 9 nodes. So this is my National Parks app that I've deployed. And down here at the bottom, you see the results of that National Parks container test. So what I did was when I built the image as part of my pipeline, I did 2 things. I wanted to check, did my image build properly? Will it functionally, will it run after I built it? And does it adhere to my security standards? So if we click on the node name in here, you'll see all of the different tests that I have defined for this. And we'll take a look in a second about how you define those profiles. They're up here. But it's essentially what we mentioned in the beginning. It's compliance as code. So you can have versioning around this. I also want to mention that, you know, in terms of waived controls, so if you have a dev environment where you're like, yeah, I don't really care, I'm going to run it kind of loosey-goosey. It doesn't need to be as secure as my customer-facing Kubernetes pods, right? You can have certain controls that get waived for those particular kinds of environments. And also there's settings like, you know, down here we have verify your app armor profile if it's applicable. So that question mark next to that one actually means that it was skipped. And you can basically say, hey, if these certain conditions evaluate true, don't bother running this particular control and test. And then if I expand out the test results, you'll see that you know, basically what I did was after I spun up my application in the pipeline with Docker Compose, what I did was I went out and I checked that the container exists, that it's running, and that it's listening on port 8080. So that's my very basic functional test. There's all kinds of things that you could add in here if you wanted to. In terms of exposed ports, if you look at this hash of information, it's a lot of results. But if we look at the source, what I'm doing is exactly that example that I checked, which was what are my configured exposed ports? It should include 9631, it should not include 22. So if you go down here and look at the results, it's basically saying that yes, I passed all of those checks. And then in terms of things like health check instructions, so this is a CIS recommendation that you have health checks built into your container images. I do not have a health check built into my container image, so we failed that particular control. More importantly, on my Docker host layer, don't run privileged containers, right? So I am running with the privileged flag in my environment because it's just a dev environment. So this is an example of where we failed this, and also restriction of Linux kernel capabilities. So just across the different layers, the image itself, the running container, the host and environment where you're running your container, whether that's Kubernetes or just straight up you know, Fargate or Docker environments, including things like, you know, for your image using copy instead of add. So don't like just add in extraneous stuff. So what we're doing here is we're looking for add in our standard out that we're running against the Docker command. So what inspect will do is it basically extracts up programmatically all these different API calls into Docker. And similarly for Kubernetes, it actually abstracts a layer up from kubectl. And because inspect's an open source project, you can actually go in and look at exactly what commands are being run. So sometimes when I want to parse exactly what it's checking for, you can go in and look at that code if that's your jam. In terms of where we define these profiles, so first of all, Automate ships with a bunch of out-of-the-box profiles. There's 399 available here. There is also an awesome open source project called DevSec project that has this CIS Kubernetes benchmark profile, the CIS Docker benchmark profile as well, in addition to what we ship with our solution. And the nice thing about inspect in terms of practicality is you can take these open source profiles, you can take the CIS standards that are out there, and you can create what's known as a wrapper profile from inspect, which basically involves turning on the checks that are relevant for your environment and turning off the checks that are not relevant. You can turn off the checks by just simply not including them as part of what you're running, or you can actually just put in a waiver if it's something that you're remediating and you want to check again in 30 days to make sure that you've updated a setting or updated a library or whatever it is that that you need to do. So this is where we've defined our checks. So when I wrote this profile, I did the first 3 steps here myself. Those are custom. And then the Docker 4.6 through 5.9, I actually just pulled those from the CIS Docker benchmark. So I didn't have to write those or update them. They were just included as part of the profile, and it's really straightforward. There's a whole ton of material out online around how to update inspect profiles and upload them into Chef Automate or run them locally. There's a ton of different things you can do with inspect. And the inspect train, it supports Docker. There's some open source libraries out there around Kubernetes and kubectl queries that is also actually officially part of the Docker inspect train. There's a lot of different flexibility. And so when I mentioned in our pipeline about, hey, you can run inspect locally or you can trigger a scan job, this is what I meant. So you can actually run a scan job remotely from Automate against any of the different layers that I just mentioned. So these are all the different scans I was running against my container environment, so National Parks pipeline scan. And you can actually define a scan job and do a curl API command to call that and trigger it remotely, which is really nice. We have a full API token and authorization layer that secures that capability. And you can define policies and be very specific about what pipelines, which users, which groups are allowed to trigger those scans. But it's a very flexible way of running your scans against cloud environments and against container, Kubernetes, etc. So basically, if you ran a, let's see, what was the last one I ran? It's this one, 12 hours ago. You can just go straight in to see exactly what was included in that scan. And you'll see it was, it really is very specifically related to that exact scan. You can also download it as a CSV. And I also want to mention that Automate has a data extract API that you can leverage to integrate data into Grafana if that's your jam. When you're doing inspect exec, you can actually pass it a reporter.json flag as well that can send the data to Chef Automate, but also send it to a second reporting target, such as, a Grafana instance itself. I haven't personally tried that, but you can definitely specify multiple different destinations in terms of your output for your compliance and your configuration scan. So that is inspect profiles and scans in a nutshell. Let me see if there's anything else we want to cover here really quickly. There's lots of different flexibilities. I mean, as you're going through your pipeline, one of the nice things about building your container with Habitat and having those variables is you can then take that built container. It is automatically tagged with the application name and the version and the build version for the image. So what you can do is you can actually update your Kubernetes manifests automatically. And you could do that after you've completed the build process and validated that your image is secure. A lot of the customers that we work with want to be very specific about which users are laid down in their containers, making sure that those settings are correct, making sure that there's only the application binaries and libraries that they need within the container, especially in more secure environments. And then the whole other aspect of this is obviously being able to scan things like AWS environments, making sure your S3 buckets are secured. All those different layers are also supported by inspect scans as well. And just really quickly, in terms of running inspect locally, you'll see here that I actually just ran this on my command line. So if we talk about compliance as code, and by the way, this repo, my National Parks demo, it is a public repo. So I need to tidy up some things on my pipeline side and merge to master, and then I will share the repo with everybody. But basically in here, you have an inspect folder, and then I have my Chef Docker webinar directory. And in here, I'm saying, hey, guess what? I want to call this webinar Docker. I'm also going to leverage the CIS Docker benchmark and include that. And in my controls directory, in my example, I'm including these controls. So you remember when I highlighted sections 4.6 through 5.9 in the UI? This is where that's set. It's pretty straightforward. And then in test.rb, this is where I have more customized functional testing, image builds, exposed ports, etc. And you can version this and iterate on it and add waivers as much as you want. I also want to point out there's some great open source work out there. Here's an inspect profile for Azure Kubernetes. So shout out to our friends over at Darkbit.io. They've done a lot of work in terms of supporting and like extending what we're doing as well. So this is, an example of a scan definition for making sure that your Kubernetes in Azure is properly set up. So, ensuring that monitoring and logging is turned on correctly, that RBAC is enabled. There's a lot of different settings that you can turn on in here, and that it's the similar approach to any of the other Docker or Kubernetes scans that you would run. In terms of profiles as well, just going back to, so by the way, that's the code for, obviously I'm writing it in VS Code, but you basically you can upload those profiles into Chef Automate, and this is what it looks like in the UI. So if you have folks in your teams who might not necessarily want to be writing validation tests, but they'd like to see what's in them, they can totally just log into the Automate UI and look at the definition in there without not having to be a developer or really even having a whole lot of code knowledge, which I think is really cool. If we look at our CIS Kubernetes benchmark profile, for example, this is if you're running Kubernetes in-house on your own instances, whether that's in the cloud or on-prem, this is really the CIS setting checks for your underlying Kubernetes pods and how those are configured. So there's a lot of different settings in here, but it extends from pods across to your master and worker nodes. There's a lot of different things, and it's not that every single setting is going to be exactly what you want, but it gets you out the door with validating what your Kubernetes configurations are. And as I said, you can do an inspect exec command and just call this profile, and it will run all of these checks for you. So super powerful, super flexible, and it can plug straight into what you have set up already if you're already building containers and running Kubernetes. Cool. So that was really all I had on the demo side.
Well, hey, Neve, real quick, while you're there, go over to the settings. Someone had a question about how we scan AWS resources.
Yeah, so basically what that is there is a section in, there's a few different ways. So if you're just going against basically a Docker daemon in AWS, the way you, there's a couple of different ways you can do that. So first of all, you can go in and you can set up just directly accessing it through SSH using your keys. So personally, that's a little suboptimal. If you want to, the other way you can do this is you can go in and you can set up a direct connection into AWS using their API or using EC2. So it depends on how you want to run your environment. The way that Inspect works is there's a section called the Inspect Trains. So it understands how to query AWS resources. And then from there, you can, what I was mentioning about the Azure Kubernetes profiles, for example, what that does is it leverages the Azure API to go in and check against Azure Kubernetes resources and other settings on there. And this is where you would set that up. The other option as well in terms of accessing the cloud environments and querying that information is within your pipeline. A lot of those access layers and secrets management pieces are already set up. So typically what we'll do is we'll actually run it from the pipeline step just to make sure that the configuration is secure and valid from that perspective. So that's another way of doing it. When you're running from Chef Automate, the way that this integration works, typically the assumption is you might want to run a quick check of what's already out there in your environment, and you might want to do that on an ongoing basis. So we do have the ability to, once you've integrated the cloud environment, to run those compliance scans on a repeated basis. Hopefully that answers the question.
I hope so too.
And you can parse, by the way, on AWS especially, you can do matching on subscriptions, different IAM roles. You can do searches by, asset tags, not asset tags, different tagging that you might have in your environment. So depending on what your tagging strategy is, you could also leverage that. And that works really well. Cool. Awesome. So let's go back over to our Google Slides really quickly. So key takeaways, Galen.
Awesome. Thanks, Neve. Yeah.
Oh, sorry.
All right. Next slide. There we go. Perfect. So yeah, so Neve just showed us how this all works at a great level. And really the idea here is that we're going to build security into the rest of the process, dealing with our people and culture, managing complexity, and really dealing with the fact that, as Ken and Neve both talked about, this process and approach, this architecture works not just for containerized deployments, but also for your existing legacy or enterprise critical systems. And so just to reiterate the things that we had here in the demo is we want to create these immutable builds for any application by abstracting the app from the operating system and modularizing the dependencies. This allows us to be really clear what depends upon where the application depends upon its stack and what pieces exist in the runtime. By reducing the complexity of the build artifact, we can create a minimal build artifact that is easily inspected and audited. And we have a standardized API regardless of what the actual end runtime looks like. If the application goes into a container, awesome, great, we can continue to work with it that way. But if it's an existing application that doesn't go into a container, we still have the same APIs, the same ways to interact with that application as we would for our cloud native builds. Because we include the compliance policies, part of the build packages for the OS and the application side, we can do this all at build time, really making sure that we get a secured, hardened artifact before the artifact even gets to production. One of the things this is really helpful for is as you deal with audits and compliance, particularly if you're like in the federal space, there's a process called ATO, Authority to Operate. In order to do that, you have to certify that the environment is trusted and safe. This allows us to put that trust and safety checks into the pipeline rather than having to go inspect production on a regular basis. And what this allows us to do is to drive our productivity for the business. Not only are we solving from a risk and application dependency management problem, we're also solving for a speed problem by enabling the teams to collaborate and work together and collaborate across code. We can shift this left, we can build it once, and we can run anywhere, right? All of the security and compliance testing, again, goes into the build process, not in runtime, but we can validate that across our deployments in real time by validating again in production. And so this allows us to eventually to reduce the failures, reduce the remediation times, while maintaining and increasing the velocity of the business.
Cool.
And so with that, just kind of ending on how we acquire or how we do this on the compliance side, the structure is simple. Acquire the content through Chef Compliance. We have a secure chain of custody and certified content by CIS. Use that to define your particular baseline. As Neve showed you, there's various ways to manage the particular controls that you want to apply against your systems. Use that to detect the compliance state, fix that compliance state by remediating it, and then report upon that compliance posture back into your dashboard, back into your enterprise dashboards and usability.
Cool. And just in terms of takeaways from this session, if you have any questions about what we showed today, approaches, use cases in your own environment, please reach out to us. If you're an existing Chef customer, you typically will have an account team who are more than happy to review different approaches with you. If you're not currently a Chef customer, feel free to ping us. There's a great and lively community online as well, where there's a ton of different content around, our whole approach with InSpec, as well as different InSpec profile examples and use cases. So thank you everyone for your time today.
And
Yeah,
I think
thanks,
we have
everybody.
a
We
few
have
minutes and some questions. Yes, there are definitely some questions to go through here. So let's get through some of these. I'm gonna start with some of the simple ones here. Tarun asks, when you say from scratch, does it mean Scratch is another Linux distribution built on top of Debian? The answer to that is that's actually just a very, very minimal Docker base container image. It basically just has a file system on it, and that's about it. So the idea there is this is what if you're going to create your own base image, this is where you would start. And so that we start from there to make sure we don't bring anything with us that we're not explicitly adding in from either the application or otherwise. So we know exactly what's inside that container. Anything to add on that, Neve or Ken?
No, that's exactly it. I mean,
That's exactly it. Yep.
Yep. It basically means that it's just a minimal operating system. There's another question here as well, but Habitat playing nicely with Git for version control. It absolutely does. You don't have to. You don't have to integrate it in that way, but you can, and that's typically how the updates flow. Let me see. Galen, do you know the answer to the question around European and GDPR reference module, or do we need to?
Yep. So the question is, the Inspect tool appears to not incorporate any European or GDPR reference module or feature. Can it be incorporated into its configuration files programmatically? I suspect this was asked around the time that we were showing the example of InSpec and the metadata you can put in with tags. We don't include things like GDPR or even oftentimes a lot of things around PCI or HIPAA in our profiles, and the profiles that we ship with Chef Compliance. And the reason for that is that GDPR in particular is what I call a soft control. It's to say things like you must have appropriate controls around the data, you must have a data protection officer, you must have the ability for data to be forgotten, things like that. InSpec is a really powerful test engine that's really good about checking for a specific piece of state on a system or against an API or otherwise. And so somebody has to map your organization's implementation of GDPR to the actual hard control that you'd put for that. So you'd say things like the data must be secure, therefore we're gonna make sure that our S3 buckets are non-public. as an example, or we validate that only these appropriate people have access to get to particular data. So that's really the structure of what we talk about from a GDPR perspective in particular. It's one of the things that makes GDPR compliance so difficult for organizations, is that there's no one right answer on how to solve for GDPR compliance.
Awesome. I thought there was also a question about container D. I will need to get back to you on that, because right now we support the container format for PCF. We support obviously Docker containers. I need to double check on our plans for container D. So I will get back to you all on that.
Yeah, there's some questions here. I think another question around inspect scanning AWS resources. As Neve mentioned, we can hit that either from the Automate dashboard, directly by hitting the API there, or you can actually run it from a command line as you go through there as well. We have a CIS profile for AWS as well.
Yeah, and Keith also had a question about, will there be support for inspect profiles for disastigs for Docker?
Yeah, Keith did. I know Keith well. He's a good friend. The answer is we are continuing to build on our roadmap. We've really focused a lot on the CIS profiles this year. And we haven't yet figured out exactly what's going to be on the 2021 roadmap, but disastig is definitely a key focus of interest for us as we go forward.
I hear you're going to be building it in your off time, Galen.
Careful what you say on recorded webinars, Neve.
You heard it from me first, Keith.
Yeah, there you go, Keith.
So Rohit had a question about integration of Alibaba Cloud. I need to double check on that, Rohit. I do believe that Inspec has been leveraged with Alibaba Cloud without I need to double check is the bottom line on that one. So are there any other questions? Oh, Lokesh said, can you share with us the document template on Docker and Chef's session? Absolutely, it is part of a public GitHub repo. The work that I did that Ken and I did for today in terms of the demo and the code, I basically, we created a branch, so we just need to merge that back into the overall repo, and we will share it out with everybody who participated today. Cool. I think that was, oh, there was a great question from Andre around, does Chef track baseline changes similar to Tripwire? So it's a little bit different from Tripwire from the point of view of it doesn't, I think it's a little bit less noisy than Tripwire. Basically with Chef Inspec and our compliance as code approach, we're telling Inspec what to check for, whereas Tripwire, I think, just goes out and checks all the things, and then if something changes, it will flag that as a condition. You can, however, if you're checking for certain conditions and a configuration change happens, and then you're checking that particular configuration set, that change, those timeline changes are reported back into Automate, and you can do changes over time reports and that kind of thing. And we actually have some nice timeline views about, you know, hey, was I compliant? Was I not compliant? You know, what particular controls were passing, which were failing at certain points in time. And the amount of data and the history retention in that is completely configurable. So.
All right, I think we will close it out there. We're at the top of the hour. So thank you everybody for an awesome webinar. Just a reminder that this has been recorded and we will be sending out the recording tomorrow. So thanks again, everybody, for attending, and have a wonderful rest of your day.